Okay, so now we are going to actually start graphing parabolas ourselves. Instead of looking at a graph of one, we're going to create it. So I'm on page 37, not page 21. I have to figure out why the numbering's off. Anyway, we're given a quadratic equation, a function. You can tell it's going to be a parabola because it's got an exponent of 2, so nobody needs to tell us that. We're looking at it. It's written in standard form. It's x squared minus 6x plus 5. And we've got some real specific steps that we're going to take to actually create a graph on the blank graph paper down at the bottom of the page. So the first thing we're going to do is identify our A, B, and our C. So that's easy enough. A is positive 1, B is negative 6, and C, our constant, is 5. Once you've gotten those identified, we're going to use the A and the B in a formula in step number 2 to figure out the first thing that we're going to find, which is the axis of symmetry. So here's the formula to find the axis of symmetry. It says your x value of your axis of symmetry is going to be the opposite of B over 2 times A. So our x value is going to be the opposite of B, which is going to be a positive 6, because the opposite of a negative 6 is positive 6, over 2 times 1, which is 2. So our x value is going to equal positive 3. Well, that's fine for our axis of symmetry, where our line is going to cut through. And so if you want to go ahead and go down to the bottom of the graph, I've already filled in this graph because you know how hard it is for me to graph with this crazy tablet. But the first thing I want you to do is draw your axis of symmetry. Don't worry about the other points right now. Just draw your green, or my green axis of symmetry, which is a perfectly vertical line that cuts through positive 3. That's the first thing we found. Now we've got to start to our graph, but now we've got to go find some points on the graph. And we're going to find 3 points, and then I'm going to tell you what we're going to do after that. So the first point we're going to find is the vertex. And to find the vertex, and that's going to either be the high or the low point, we are going to use the x value from this axis of symmetry, and we're going to go figure out what the y value is. So what is f of 3? Remembering, f of x is the y value when x is a certain number plugged in here and here. So let's go find f of 3. So we're going to have 3 squared minus 6 times 3 plus 5. So we just need to clean this up. We need to figure out what this is, and that is 9 minus 18 plus 5, which turns out to be negative 4. So our first point, which is our vertex, is going to be x is 3, and we just calculated the y value. The f of 3 is negative 4. So now we need to find a second point. We have our first point right here. We need to find a second point. And the next point that we're going to find is the y-intercept. Because anytime something has a y-intercept, their x is 0 because it hasn't moved off the origin. So that's going to help us when we go back to our original equation, and instead of f of 3, we're going to find f of 0. So where is the y when x is 0? So again, we're just going to plug it back in. This one goes pretty quick. 0 squared minus 6 times 0 plus 5. So we know that f of 0 is 5. So there's our second point. We said x was 0, and we calculated that y would then be 5. And our third point, we are going to go down. So go down and look at the points that I plotted in red. So this is 3, negative 4, the vertex, and there's 0, 5. So we're going to pick a point in between these two, an x value in between 0 and 3, and we're going to find what the y value for, in this case, I chose 2. So the third point, in between this point and this point, I'm going to pick an x value pretty close down here, and I'm going to pick 2. So I am going to find f of 2. What is y when x is 2? So 2 squared minus 6 times 2 plus 5. Be careful with your signs. That's 4 minus 12 plus 5, and that ends up being negative 3. So f of 2 is negative 3. So our ordered pair would be 2, negative 3, which is my third red point down here, 2, negative 3. So once I've plotted these 3 points, I can go to the other side of the axis of symmetry and plot points that are exactly the same distance away on the same y line that I've already plotted, because I know that the axis of symmetry is going to divide this parabola exactly in half. So those are my blue points. I come over to this point. He's 1 unit away from the axis of symmetry. I go to the other side and plot a point that's 1 unit away. Up here, my point is 1, 2, 3 units away, so I'm going to go on the other side of the axis and go 1, 2, 3 units away. And now if you have a better hand than I, you can go ahead and make your big U. I don't know if I can do this good or not. Hey, not too bad. Little bump right there. So this is our parabola that we have created just based on the equation that was given to us. So I'm going to stop here. We're going to do 2 more in the next video. We'll do example on page 38, 2A and 2B, and then we'll practice some in class as well. Bye.